Let's do an example. So now we are going to find the deformation of this concentric wooden cylinders. There are 3 loads applying on it. Those 2 pieces are sticked together. They are one piece. They are not separated. Okay. So in order to do this, we need to consider the free body diagram of each of them. So we need to identify the external load exerted on each segment. So we call it segment 1. This is segment 2. For segment 1, as you can see, there is a PA of 20 kN transferred here. And also, since those 2 pieces are sticked together, if PC is exerted on segment 2, then the segment 2 will also pull this surface to the right hand side. Therefore, we conclude that there are 3 forces in total acting on this surface, and the resultant will become tensile 20 kilonewtons. This beam is clamped to this wall. And in order to remain this segment static, there will be a 20 kilonewton reaction given by the wall. Therefore, this segment is in static state and it is in tensile stress of 20 kilonewtons. What we can do is to use the alpha formula. Delta equals to P1L1 divided by E1A1. Well, the Young's modulus is the same for both of them, while the applied load is what we know. Remember, try to convert everything into the SI units first to get rid of confusion. Then you will get the result of 0.252 millimeters, which is very small in comparison to the original length. How about segment 2? PC is 25, PB is 15, PA is 20. But it is not the end of the story, because you can see it is obviously not in static. But there will be P1 equals to 20 kilonewton applied here, because as a reminder, we know that there is a 20 kilonewton P1 applied here, applied at the segment 1. Therefore, there will be a 20 kilonewton reaction pointing leftward, acting on segment 2. Consequently, the resultant of the system will become 20 kilonewton in compressive form. Therefore, we can calculate the deformation by using the alpha, PL divided by EA. Notice that in the compressive form, the P, the applied load, will become negative. The deformation, even if it is compressive, is much more smaller than that of segment 1. Therefore, what we can do is to add them up. Add the deformation of the whole piece together, which is delta 1 plus delta 2. Notice that we will account the symbol as well, because for segment 1 it is elongated, while for segment 2 it is shortened. The total deformation will be 0.236 millimeters. You can try this problem yourself after viewing this video.